Okay, so if you're watching this video, you should have tried doing this problem on your own. If you haven't, then stop the video right now, do this, then check your answer against what I post into Schoology. This is a formula, so why did we learn about dot products? This is a formula that we can use to find the angle between two vectors. Defining this and getting this formula is a bit crazy. I didn't want to put you through that process, so I'm just going to kind of put this up here for now. Okay. Just understand that if you have two vectors and they're just labeling them as any two vectors, u and v, if you find their dot product, put that number on top of this fraction. Find each of their magnitudes separately and then multiply them. That's why they're pushed together. That's a product. The cosine of the angle between them is equal to that number. So really, to find the angle, we'd have to take the inverse cosine of this. So let's practice. Suppose I have this vector u, and remember, linear combination form is the same as component form if I write it like this. And then suppose I have vector v, has no I term, so I'm going to write that as 0, and its j term is -7. So the first thing, there's two parts to this. We need to know the dot product and we need to know the product of their magnitudes. So for the first thing, and I'm going to let you figure this out on your own, okay? You should be able to come up with that magnitude on your own at this point. You should have been practicing it quite a bit to get up to this point. But this is the square root of 45. The magnitude of v is actually kind of nice. We get 7 for that, right? Think about it for a second. Why is the magnitude of this vector 7? Because the magnitude is the length, and if this vector goes from 0, 0 to 0, -7, and it just does this, then this distance is 7 units, right? We don't have to worry about going off on an angle and being the hypotenuse of a right triangle, so on and so forth. So we have these two values for the magnitude. In terms of the dot product of u and v is the product of these numbers, 6 times 0, plus the product of these numbers, which is 3 times -7. So we get 6 times 0, which is 0, plus 3 times -7 is -21. So we get -21 for this. So up here we have, sorry about that. The magnitude of v is 7, the magnitude of u is radical 45, and their dot product is -21. So if we bring in the formula now, the cosine of theta, and this is just, again, this is the angle between u and v, okay, that's equal to their dot product, which is -21, over the product of their magnitudes, which is radical 45 and 7. Now, in order to find this angle, like this doesn't mean anything, that's a variable, right? So to solve for this variable, I have to do the inverse operation of cosine to eliminate that. So I have to take the inverse cosine of both sides, right? So I'm doing this, just for, spell it out. I have to take the inverse cosine of all of this, and I have to take the inverse cosine of all of this. When I take the inverse cosine of cosine, those cancel each other out, and that leaves me with theta. Over here, I'm going to Desmos for that. So the way I'm going to do this is I'm going to do the inverse cosine of, on top we had -21. On the bottom, I'm going to go in parentheses here. We had the square root of 45 times 7, and this is all under that square root. So take a look at the way, oops, that didn't work, did it? Hold on, there's a mistake. Start over. Square root of 45, arrow over, times 7. So we have the square root of 45 times 7 on the bottom. That's the product of the magnitudes. We have -21 on the top. That was their dot product. We're taking the inverse cosine. We get 116.6 for this. Okay, so whatever this whatever this mess ends up being. So we had this. Theta was approximately 116.6 degrees. This is what you should have gotten for this problem. Okay, check it, make sure we're good.